Hello everyone! In this video we're going to be covering the top 10 mistakes that some algebra students make. I've taught hundreds of math students and I noticed that some of them make these repetitive mistakes. Let's now start with mistake number 1. If you think that the square root of x squared plus y squared is like this, then of course this will be wrong. So some students say it's the square root of the first one x squared, which is x, plus the square root of the second one y squared, which is y. Now, following the same logic, they would say the square root of x squared plus 25 can be written like this: square root of the first one plus square root of the second one. Now here, cancel the square and the square root, it would be x plus, and here we have square root of 25, which is 5. And of course, this is wrong. To understand why it's wrong, see this example here. Square root of 9 plus 16. We will get, if we apply this, we will get square root of 9 plus square root of 16. Square root of 9 is equal to 3 and square root of 16 becomes 4, and 3 plus 4 is 7. See here now. 9 plus 16 is of course 25, so this is basically square root of 25. As we know, square root of 25 is 5, but here what we got is that square root of 25 equals 7. So square root of 25 at the end, as we got 7, which is of course wrong, and the reason is this: because we distributed the square root over this addition. So square roots cannot be distributed over plus or minus. But now, the correct way to distribute square root is that when you have multiplication or division. So for example, here, this would be correct. Square root of 16 multiplied by x to the power of 4 multiplied by y to the 6, for example. Here, it's all multiplication. So it can be the square root of the first one times the square root of the second one and the third one. Now, square root of 16 is equal to 4, and square root of x to the fourth will be just x squared. We have the power. And square root of y power of 6 would be y cubed. So this is the correct way to distribute square roots over multiplication. Let's move on now to this mistake. X plus y squared is equal to x squared plus y squared. So they basically distribute the square over the first one and the second one, and of course this is wrong. So here, following the same logic, then we can say x plus 3 squared is equal to square the first one x, which will be x squared, and square the second one 3. It will be 3 squared. So this is x squared plus 9. And this is never true. To do it in the correct way, we can do x plus 3 squared like this. We know that anything squared means it's multiplied by itself twice, like this. And now we're gonna FOIL this or expand this completely. So we will multiply x by x and then x by 3. Then 3 by x and 3 by 3. X by x, we will get x squared, then x by 3, 3x, and then 3 times x, also 3x, and 3 multiplied by 3 would be 9. Simplify this, it will be x squared. Here we have 3x and 3x becomes 6x plus 9. So as we see, this is the correct way to expand this. Here, 6x is missing from this wrong solution. Let's now move on to the absolute value. Now we know that the absolute value turns a negative number into positive. So the absolute value of negative 7 is positive 7. And the absolute value of negative 8, for example, would be 8. The absolute value of positive number like 2 would be still positive 2 as it is. But a common mistake that some students make when they have an expression like this, x minus 7, they would say the absolute value of positive x is as it is, and the absolute value makes the negative 7 positive, so it will be x plus 7, and this is wrong. The absolute value turns the negative number into positive when you have just a single number inside the absolute value, not when you have a sum or difference or subtraction. So this is wrong. To understand why this is wrong, if we follow the same logic here with 9 minus 7, let's say, so if we follow the same logic here, it would be 9 as it is, and the minus 7 would be plus 7. 9 plus 7 would be 16, where of course this is wrong because 9 minus 7 is 2 inside, and the absolute value of 2 should be 2, not 16. Another common mistake with the absolute value is that when we make the absolute value of negative x positive x like this. Now, of course, this is still wrong. As we said, we can apply it when we have single numbers inside, not variables. So here, in this expression, the best that we can do is this. The absolute value of negative x is the same as the absolute value of positive x, but it cannot be equal to x as we have here. So all of these are wrong and these are correct. Let's move on now to dividing or multiplying both sides of inequalities by negative numbers. So here we have an inequality which is waiting for us to do the final step, which is dividing by negative 2 to find x, to solve for x. So here, if we divide negative 2x by negative 2, it would be just x, and if we divide 4 by negative 2, it will be negative 2. Now, of course, this is wrong, because whenever we divide or multiply inequalities by negative numbers, we have to switch the sign or the direction of the inequality. So if we have negative 2x less than 4 and we need to divide by negative 2, it becomes x greater than negative 2. As we see here, we flip the direction of the inequality. To understand why we flip the inequality, take this example. 2 is less than 4, of course, as we know. Let's multiply both sides by any negative number. Let's say, for example, negative 3. If you multiply 2 by negative 3, it would be negative 6, and the 4 would be negative 12. Compare them now. Which one is bigger here? Of course, negative 6 is bigger, so that's why, as we see here, the inequality is flipped. Let's move on to dividing by variable x, or dividing by variables in general. Here we have a quadratic example. So here a student might see that here we have only two terms and both of them have x. So let's divide by x to make it simpler. If we divide by x, we will get x squared divided by x will be x minus, if we divide 5x by x, we will get 5. So x minus 5 is 0, then x will be positive 5. So the solution is 5, and really when you replace x by 5 here, it makes the equation correct. Now this part of the solution is correct, but incomplete. So if we do it in this way, we would lose some points in the question, because we have another missing solution, which is x equals 0. Try to replace x here by 0 and here by 0. So you will have 0 minus 0, which is really 0, so it's correct. So to do it in the correct way now, we do it like this. Instead of dividing by x, we can factorize the x out. Then we will have x minus 5 inside equals 0. Since we have a product equals 0, then either the first one is 0, so x equals 0, or the second product, x minus 5 is 0, then x will be 5. So as you see here, we have two correct solutions, but here we got only one of them. Let's move on to simplifying fractions. Here, some students, when they see a fraction like this, they might say cancel out 3 and 3, so the answer is 4x divided by 5x, or probably Further, we can cancel x and x, so the answer would be 4 divided by 5. And of course, this is wrong. And here in this fraction, actually, we cannot cancel or simplify anything at all. So we keep the fraction as it is. In this fraction down, also if we cancel 3 and 3 and say the answer is x plus 12, it would be wrong. Or even if we divide 12 by 13 and say that the answer is 3x plus 4, then this would be wrong again. Here, to simplify this fraction, we can do it like this. We notice that all of the numbers are divisible by 3, so we divide all of them by 3. If we divide by 3, 3x would become just 1x, 12 divided by 3, 4, then 3 divided by 3 down 1, and of course, we don't need to write a denominator of 1. Another way to simplify this, you can factor 3 out from the numerator. We will have x plus 4 and keep the 3 down, cancel out 3 and 3, so we have x plus 4. Let's move on now to multiplying fractions. Here we have 5 multiplied by this fraction. So a very common mistake would be when we multiply 5 by the numerator and denominator. So 5 multiplied by 2 would be 10, and 5 multiplied by 3 down would be 15, and 10 divided by 15 can be simplified to 2 over 3. As we see, it was 2 over 3, and now it's still 2 over 3 after we multiplied by 5, and this is illogical. To do it in the correct way, when we have fraction like this, 5 multiplied by 2 over 3, we imagine that we have a denominator of 1 here under 5, and we just multiply numerator by numerator and the denominators by each other. So here, 5 multiplied by 2 would be 10, and down, 1 multiplied by 3 would be 3. So this is the correct way to multiply these fractions. In the same way here, we cannot multiply 2 by the 5 and the numerator and say 2 multiplied by 3x, 6x, then 2 times 7, 14. Down, 2 multiplied by 5 would be 10. This is wrong. To do it in the correct way, again, we put a denominator of 1 under 2. So now, we multiply 2 only by the numerator. We will have 2 by 3x, which is 6x, 2 by 7, 14, and down we have 1 times 5, which is 5. So this is the correct way to multiply fractions. Another common mistake with fractions is that when we see 16, for example, equals 8 divided by x. So here, some students would say, make it x equals 16 divided by 8, which is 2. So x would be 2. And of course, this is wrong because if you replace x by 2 here, 8 divided by 2 is 4, not 16. To do it here in the correct way, if you have 16 equals 8 divided by x, then first you can swap these and say x is equal to 8 over 16, which is half if simplified. Or another way to cross multiply. Here we have 1, then cross multiply 16 times x equals 8 multiplied by 1, then divide by 16, x will be 8 over 16 again, which is half. Let's move on now to this very common mistake. Here we have negative 4 squared. Some student would say that I learned when we square a negative number it becomes positive. So negative 4 squared becomes positive 16. And of course this is wrong. Yes, we know that when we square a negative number it would be positive, but here we're not squaring a negative number. Actually here we are squaring only the 4, not with the negative, because only 4 is under the square, not like this negative 4. So here to do it in the correct way, actually it is negative as it is. The 4 squared can be written as 4 by 4. 4 by 4 is 16, so it's negative 16. So in what situation we can write negative 4 squared equals positive 16? It would be in this case when the negative also is under the square with the 4. Here this becomes positive 16 because it's actually negative 4 multiplied by itself. Negative 4 times negative 4 would be 16. So these are correct, but this is wrong. A very common mistake with this in the calculator is that when students try to solve some quadratic equations like this using the quadratic formula and the calculator. Here, as we see, a is equal to 6, b is negative 11, c is 4. So when they put it in the calculator, they put it like this. Negative b, so negative 11 plus or minus. Now here, when it comes to b squared, they would say, for b squared, they would say negative 11 squared. Then minus 4 times a times c, all divided by 2 times a. And then, surprisingly, the calculator tells them that error, or you cannot do this. And the reason is that here we have b squared or negative 11 squared. Here we put just 11 squared and the negative is outside. So to put it correctly, we put the negative 11 in brackets like this and the problem will be solved. Let's move on now to multiplying the base of powers. Here we have an example. So in the wrong way to do this, some might say we multiply 2 by 5 first, which will be 10, and then we have square. And now 10 squared is 100. So the answer here to this would be 100. And of course, this is wrong. To do it in the correct way, we can do 2 multiplied by 5 squared like this. First, according to PEMDAS, we do powers before multiplication. So we square the 5 first, which will be 5 squared 25. And now 2 multiplied by 25 would be 50. This is the correct way. Another common mistake with powers and bases is like this. Example here, 2 multiplied by 4 to the x equals 64. So here, if we do it in the wrong way, first we multiply 2 by 4, which becomes 8. So we have 8 to the power of x equals 64. As we know, 8 to the power of 2 is 64, which means here x would be 2. And of course, this is wrong, because if you check 2 here, if you replace x by 2, you will have 4 to the power of 2 first, 16. Then you will multiply by 2. 16 by 2 will be 32, not 64. Let's move on now to square rooting when we have a positive and a negative answer. Here we have x squared equals 16. So some students would do it like this. If x squared is equal to 16, then we would have x equals 4. Because when we square 4, it will be 16. Now, this part of the solution is right and correct, but it's not complete. We have another solution, which is negative 4. So here, the correct way, the full way would be, if x squared is equal to 16, then x will be positive negative 4. Because also, negative 4 squared would be positive 16. Example now, like this, x plus 3 squared, and all equals 25. So here, instead of expanding the bracket and having a quadratic and moving, we can directly square root both sides. X plus 3 without a square equals not only 5, it will be either 5 or negative 5. Here, x would be positive 2, and here if we subtract 3, x would be negative 8. These are the correct solutions to this equation.